This is the final video to our series on data enrichment with Elasticsearch. There are two videos prior to this, so if you haven't seen them yet, I will leave a link to both of them in the description of this video. So let's move on to this final part. I want to demonstrate another practical scenario. I want to demonstrate how to use an open source tool called Logstash and some basic Linux shell scripts to automatically ingest and enrich data in Elasticsearch and Kibana. I also want to demonstrate how to enrich data when indices have at least two tiers of hierarchical relationship. The data I'm working with will reflect an e-commerce scenario, which you can see on my screen right here. I have 5 data sources. Right now they are in the form of CSV files, but they could be any combination of actual databases, document types, APIs, or just simply other services. Logstash can be configured to ingest quite a few different data sources, but I'm sticking with CSV files just to be consistent with my earlier videos. So I was saying, I have 5 different CSV files to reflect an e-commerce scenario. And the scenario here is that customers can buy products. The orders.csv file reflects what customers have bought. And the orders CSV file has 3 columns. It has the customer ID, order ID, and purchase date. To actually get details about the customer, you have to look in the customer CSV file. And you need to look for the row in the customer CSV file with a customer ID that matches the customer ID of the orders CSV file. And to know what items the customer has bought, you actually need to look in the order item CSV file and look for all rows where the order ID matches the order ID of the order CSV file. And there's one more step. To know the product details, you actually need to look in the product CSV file, look for the row with the product ID that matches the product ID of the order item. The other thing I'll say about this order item table is that normally you would see other fields in here like quantity sold and taxes, but I've omitted those fields from this file so that it doesn't distract us from learning about data enrichment or ingestion pipelines. It is more important that we understand the relationship between all these entities. And one more thing, in the customer CSV file, we have a zip field, but we do not have geographic data in this CSV file. So what I have instead is a separate CSV file where you can look up latitude and longitude based on zip code. So that's the relationship between all these different data sources. But in terms of the actions we need to take, we need to actually go from right to left. And that's because we need to start with source indices with the fewest number of dependencies first, and then work our way towards the order index. So the first thing I'm going to do is I'm going to import the zipgeo dataset into an index. And once I've done that, I'm going to set up a zipgeo policy that does an exact value match on the zip code so that it can enrich with the geopoint data field. Once that is set up, then I'm ready to import the customer dataset. When I import the customer dataset, I'm going to use an ingestion pipeline that leverages the zipgeo policy so that we get the enrich geopoint data field as part of these fields over here. And once that's done, I might as well set up the customer policy here so that the customer policy will do an exact match on the customer ID field so that it enriches with these address fields as well as this zipgeo code field as well. The order CSV file import eventually will need to leverage this policy, so I might as well set it up in advance. All right, once this workflow up here has been accomplished, then we can move on to this one down here. I'm going to import the product dataset into a product index. Then I'm going to set up a product policy that does an exact value match on product ID so that it enriches with the name and price fields. Then I'm ready to import the order item dataset. And when I import the order item dataset, I'm going to use an ingestion pipeline that leverages the product policy so that these product details become enriched fields within the order item index. And once the order item information is there, I will set up an order item policy that does an exact match on the order ID and enrich with the product detail fields over here. All right, so we've got customer order item in place. Now, all we need to do is set up an ingestion pipeline that leverages the customer policy and the order item policy while we import the order data set. And once we have all the orders in an index, when we do a search, we want a result that looks somewhat like this. You can see all the green fields are the source indices that were on the far right in our previous diagram over here. And all the orange fields are the enriched fields from all the middle source indices in this diagram here. And the white field is basically the original incoming document. And I forgot to put in the purchase date, but hopefully you guys get the idea. One more thing I'll mention is that every single field type here is pretty much just a string or number, except for this point field over here. This point field is a geopoint data type or field type. So we're going to have to explicitly map this field as a geopoint field during the upload of the zip geo, and during the upload of the customer, and during the upload of the order. So at this point, I think we're ready to get started with the setup. I uploaded all the resources that we'll need to this Git repo, and I'll leave the link in the description of this video. We're now doing part 3. So it's got a very similar setup to our previous exercise, where I have a folder for data, mapping, pipeline, and policies. These will contain all the things that we'll need for this video. If I open up data as an example, we have our customer CSV, order item, product, and zip geo. Let's open up each of these quickly. All right, the customer CSV file, I actually got it from the public domain from kaggle.com, and I just reused what they gave me. So pretty straightforward. For the order, we only need the data.csv. This data CSV was generated by a random function inside this data Excel file. I thought in case anyone finds the Excel file useful to generate more random data, you can use it, but you should be okay with just the data.csv. And if you open it up, basically all the fields we stated in this PDF: order ID, customer ID, purchase date. Order item, same idea. Here's an Excel file to generate some random data, or you can just take the random data that I've already generated, and this will just have the order ID and product ID. Okay. This is the product list. I just handcrafted some fake products, like a laptop for $3,000, computer for $2,000. Pretty straightforward. And this is the zip code to latitude, longitude, latitude. These are not real, right? I just randomly generate some latitude and longitude so that we can plot it on a map. If you want to generate more, you can just use the Excel file here. So those are our data files. And the mapping folder will just have all the maps, the Elasticsearch index maps that we would be using. And same thing for the pipeline and policy. These are all the pipelines that we'll be setting up, and these are all the policies that we'll be setting up, and I'll explain them in more detail as we go through. I also have a Logstash folder. We're going to be using these configuration files pretty early on, and I'll explain how they work in a moment. So that's how this folder structure is set up. Okay, so let's check out this project to an Ubuntu server. So I'm going to grab the Git repo URL over here. And this right here is a new SSH session to an Ubuntu server, Ubuntu 20.04. I don't have anything else installed on it. So let's make a new folder here. Great, so everything should be here. We go into part 3. Yep, so all the files we need are in here now. Now, one of the first things we want to do is ingest CSV files. And we're going to use an open source tool called Logstash to do the ingestion. And let me pull up the installation instructions for Logstash because I don't have that yet installed on my Linux machine. And it's basically just the get a public signing key, install a dependency, update the repository definition, do an update, and then install Logstash. So it's really just these 4 commands. So let me copy each of these. Copy. All right. And let's take this one. And let's update the repository definitions. And then finally install Logstash. Great, Logstash is installed now. Now, if we take a look at this directory again, we will see 5 shell scripts. 1, 2, 3, 4, and 5. Each one of these scripts will represent one of the CSV files that we are about to upload. And we will execute each of these scripts in the order that they are labeled. So 1, 2, 3, 4, then 5. So let's see what's in the first script. So this first file will set up everything about zip.geo. So I'll just go line by line and explain what's going on. First thing it does is include an environment file. So I actually have to set that up first. I have a sample file that we can work from. And first thing we'll do is update the project path. What is it? It's this. And let's provide the host for Elastic. And you can use an IP address as well. I am using SSL, so I'm going to use the value true. Any other value placed in here will cause my shell scripts to not use SSL. I'm going to use the super user just to keep things simple for now. But ideally, you want to use a less privileged user. Okay, so that's done. So now this line can properly import the environment variables into this script for us to use. Next is the variable HTTP protocol. By default, all REST API URLs will simply be using HTTP, meaning no SSL certificate will be used for encryption. But because we set the environment variable Elasticsearch to be true, then the host protocol will now become HTTPS. Okay, next line. The first real action we will take is we are going to make a put request to our Elastic REST API. We are going to use our super user credentials to connect to HTTPS elastic.everbyte.net, and then we will create a new index called zip.geo. Next, we will define an index mapping for zip.geo. The mapping we are going to use is found in the mapping directory of our current Git project. So let me open that up and let's take a look at the mapping details. So this is the mapping that we will tell Elasticsearch to use so that Elasticsearch knows what field type to use for each record we transmit to it. The only field I needed to explicitly define is the point field. We need to explicitly define it as type geopoint. I could have omitted the field zip from this mapping because Elasticsearch has no problems recognizing simple field types like numbers and strings, but there's no harm defining the zip field here anyway, so I left it as is. The real important one is the point field because it's not a straightforward field to work with, and we need to make sure Elasticsearch is aware of this. So that's all this command is doing. It's submitting this mapping to Elasticsearch so Elastic knows what field types to use for each incoming document. Okay, so this line here, let me set the line numbers. This line here is saying open the contents of logstash/zip.geo and read it into this variable logstash.conf as a string. All right, so then what does zip.geo conf look like? Let's take a look. So on the left, this is what the Logstash zipgeo.conf looks like. This is officially called a Logstash configuration pipeline. This configuration pipeline tells Logstash where to read data from and where to give the data to. This first stage here, this input stage, is saying read the contents of /data/zipgeo/data.csv. So that's basically, so open up this file, right? And then we're going to start reading from the beginning of that file. And we're going to log any unusual details to some hidden file here. Then we are going to convert two of the columns. We're going to convert the zip field to an integer, and we're going to convert the point field to a string before we pass all that content over to Elasticsearch, right? And these are the connection details that we're going to use for Elasticsearch. So that's what this configuration pipeline is saying that it will do. Now you're going to see a lot of these hashtag project path or hashtag elastic host, elastic SSL, elastic user, elastic pass. Now these are just my placeholder strings, I guess. And what's happening is I'm going to use shell script. I'm going to take this variable. I'm going to find all instances of hash project path and replace it with the variable project path. Right? And this project path is what was defined in our environment variable. So I'm just doing some variable substitution within this file itself using my own type of syntax. So that the end result, what this file should end up looking like, actually, let me pause for a moment and I'll fill out the details. Okay, so by the time you get to line 24 here, once all the variable substitutions have taken place, this here on the left, this is the content that's eventually going to be fed into Logstash. And we're going to set up the zipgeo in the index zipgeo over here. Okay. So now the Logstash conf variable has all the configuration pipeline details stored as a string. We'll pass the Logstash conf variable to the Logstash command, and Logstash will then take the zipgeo CSV file to populate a zipgeo index in Elastic. Okay, so once that is done, the next command that happens on line 27 is we're going to set up the zipgeo policy. We're going to ping this endpoint, and we're going to call our policy zipgeo policy, and the policy we're going to use is found in this file. Okay, so we're going to use the zipgeo index. We're going to match on the zip field, and we're going to enrich with the point, the geopoint field. Next, I'm going to wait 30 seconds. The reason is because the next line, on line 32, I'm going to execute the zipgeo policy. The execute command creates an enrich index based off of our zipgeo source index that we populated on line 25. If you recall, the enrich index is a behind the scenes index that is completely managed by Elastic, and it is critical for ingestion pipelines. So if I run the execute command too early and before Elastic has had time to completely ingest and process data in my zipgeo source index, then the enrich index may not have the latest information. Then I'd have to correct the situation again later by running the execute command anyway. So I might as well put a sleep 30 seconds here on line 31 to give Elastic some time to do whatever it needs to do with the source index before making the enrich index. And that's all this script does, and we should be able to run it now. Okay, so it might take a few moments, so I'll pause. All right, looks like everything should have been loaded. Let's take a look in here, and I'm going to go to stack management. And then I'm going to index management. I'm going to show all indices because I want to see if the zipgeo appears in here. Number 2. Well, we can see the enrich index. Great, there's 234 in here, and that's how many records there was in the CSV file. And zipgeo itself also has 234 records. So that's it. We've got the enrich index and the policy set up for zipgeo. Let's move on to the next file, which is the customer file. Okay, so this is very similar to zipgeo, but I'll point out the differences. First thing is load the environment file. We're using SSL. Set up the index called customer. Here. On line 11, we're going to set up the mapping, and we're going to use the customer mapping. So let's take a look at that. So the only field we need to explicitly define is the geo.point field, which is of the type geoPoint. The field geo is a nested field that we will use to contain the enriched fields that we get from the zipgeo policy. And the only enriched field we are getting from the zipgeo policy is the point field. Every other customer field is a straightforward field type, so we will let Elastic automatically map those. Next is we actually need a pipeline. We need a pipeline because we want to use the policy from zipgeo. And what does that pipeline look like? So we are saying we want to set up an enrich processor using the zipgeo policy. In our CSV file, in our customer.csv file, we are going to be looking at, we're going to be matching on the zip field, and we're going to throw all enriched fields into a target field called geo and return only one document. So that's what our ingestion pipeline will look like. And next is we're going to load a Logstash configuration file, and it's a Logstash customer.conf. Right, so this is basically like zipgeo in the sense that we're going to read from customer/data.csv, start from the beginning of the file, and make sure the customer ID is an integer, address is string, city is string, state is string, zip is integer, birth year is integer. Have the correct data type there before sending it over to Elasticsearch. Then we'll connect to Elasticsearch with these credentials here and throw the content into a customer index, and we'll be sure to use the customer pipeline that we defined just moments ago. All right, so there we go, run Logstash. Next is we're going to set up a customer policy. And what does that policy look like? It looks like this. We are going to leverage the customer index. We're going to match on the field customer ID, and we're going to enrich with these fields here. Right? Pretty straightforward. And again, I'm going to wait 30 seconds before running the execute on the customer policy, just to give Elastic some time to load the data that it needs to load and process it. So let's go ahead and just run this. Okay, looks like things should be done. Let's take a look. Reload indices, and do I see a customer index? I do see the customer policy. Great, there's 234 records. That's what I was expecting. That's how many records there were in the CSV file. So the policy is okay. Right, and the index here is also okay. All right, so let's move on to the next file. Next, let's load in products from the products.csv file. This time, we do not need to specify any mappings because the product.csv file only has keyword and number fields, and Elastic is smart enough to know how to automatically map those. We don't need any ingestion pipelines to leverage any existing policies. We are simply going to run Logstash based on the product Logstash configuration file. Let me open up the Logstash configuration file. Here we just load in the product/data.csv file. Then we make sure Logstash recognizes the field types for every single column before sending it over to Elastic. Then Elastic should place all the documents in an index called product. Next, let's set up the policy. The policy says we will use the product index, then we will match on the product ID field, and we will enrich with the field's name and price. So nothing special in this policy. Then we'll wait 60 seconds before executing the policy. I'm not sure why I chose 60 seconds instead of 30 this time. I think maybe the last time I ran these scripts, it took a bit longer for product source index to be ready. Anyway, 60 works, so we'll just stick with 60. So let's run this script now. Whoops, wrong one. Okay, let me exit. There we go. Yeah, let's do this. And we'll give it a moment. All right, the product index should be set up now. If I hit reload over here, oh, great. At least we see the enrich index first. 25 records, that's actually how many were in the CSV file. Let's take a look at page 3. Great, there's 25 records in the product index. All right, we're good there. Let's move on to the next one. 04. Order item. Pretty much the same thing, except this time the order item needs a pipeline because the order item pipeline will leverage the product policy. So let's confirm that. Pipeline order item. Yes, so you can see that to ingest the order item CSV, we need to enrich it with product data. So we're going to use the product policy. We're going to match on the field product ID, throw all enriched fields in the target field called product. Okay, then we'll use Logstash to ingest the CSV file and pass it over to Elastic. So let's take a look at that. Logstash order item. Right, so just read this CSV file from the beginning and then just make sure that they're both order ID and product ID are integers and give them over to Elastic. Elastic should throw all the records into an index called order item, and let's use that order item pipeline that we set up. So let's go ahead and run that. All right, order items should be in. Reload these indices. Yep, we've got 23,000 records for order item index. That's what I was expecting. Let's make sure our policy is okay, our enrich index. Yes, 23,000 records are in there as well. Okay, so now we're on to the last one. 05, this one here. All right, so first thing we're going to do is set up the order index, and then let's set up the mapping. And in this mapping, I'm going to let Elastic automatically map most of the fields. I'm going to explicitly define customer.geo.point as the type geopoint. The customer field is a nested field. The ingestion pipeline that we will set up in a minute or so will throw all enriched fields into this customer field. In the customer field is a geo field, and the geo field will contain this enriched point field. Next, we are going to need to set up an ingestion pipeline. So let's take a look. This ingestion pipeline will need to leverage two enriched policies. We will need the order item policy. We will match on the order ID field of our incoming document. We will throw all the enriched fields into a new and nested order items field, which will be an array. The policy will return up to 100 enriched documents. And as of Elastic 8.6, the maximum value for max matches is 128. This is for performance reasons. You should check with the documentation of your Elastic version to know what the maximum value you can supply for the max matches field. The other policy we need to include is the customer policy. We will match on the customer ID field of the incoming document and throw all the enriched fields into a new and nested customer field. And we will only return one document. So that's our ingestion pipeline. Next, we will have Logstash consume our CSV file and give it over to Elastic. So let me open up the Logstash configuration file for our orders. So Logstash is going to read this file, right? Read the data/order/data.csv. Just make sure order ID and customer ID are integers. Give all these instructions to Elastic, or give all the data to Elastic. We're going to throw all the records into an index called order, and we're going to use that order pipeline that we just set up. All right, let's run this. All right, all the orders should be in. If we go to our indices here, let's reload them. Enrich order item, let's go to page 2. Enrich. Oh, I don't need, yeah, there was no policy for orders, so never mind that. But there should be an index for order here. Here it is. And, oh, it's got no records in there yet, so it might just need some time. And the other thing what I can also double check is, oops, let's go to our dev tools and let's just do a search, because sometimes it might take more time for this row here to reflect changes. Great, so there's 10,000 records so far, and you can see that for each order record, we see the order items has been enriched here, customer details have been enriched. In fact, this is the cool part where it's nested, right? So we see that customer was enriched with these fields, and this geo was enriched with these fields. So if we go back to our slide over here, this was what we were trying to achieve, right? 2 layers or 2 levels of enrichment. Okay. And let's see, anything else? No, I think so. This is good. So this worked. Let's just see if the stats here have been updated. There we go. So now we see 10,000 and 12 records. All right. So with all that said, I'll mention one more thing. We've ran each of these scripts separately, but to speed things up, I made this other script called run.sh, and inside this file, I reference all 5 of these files. So next time, you can just run the run.sh and it'll execute the other scripts in the order that they were meant to be executed. In fact, let's do that right now. I have a teardown script which will destroy everything we've just made, so we can do this all over again. So let's tear down, and let's go ahead and run our script. This might take a moment, so I'll pause for a moment. Okay, everything is imported. I think it took about 5 minutes or so. Let's do our same check over here. Yep, we see the enriched data in here. So we're in pretty good shape. So let's do a sanity check as well by setting up Kibana lens, or maybe even the heat map again, just to make sure that all the field types are what we expect them to be. We'll start with the heat map, just to make sure the geopoint data field is mapped correctly with the right field type. And let's choose heat map. Ooh, oh right, because I was expecting orders to show up here, but it's not there yet because we didn't set up the Kibana data view just yet. So we will do that right now. Go down to data views, create a new data view, order, and great, there's a timestamp. And now if I hit refresh on this page, right, I will press add layer heat map. There we go. We have the order data view now, and you can see that customer geo point was recognized. Let's use that. And let's do again the revenue made in particular regions in the world. So sum on the field of order items dot product dot price. Great. So all the enriched fields are now available to us here, and we can see that right there. Yeah, let's zoom in on this area. So you can see all the sales that are happening in these areas now. So I'm just going to save this. All right, and we'll just do one more visualization. Great, this one's over here. Okay, let's do one more visualization. We'll use the order data view. And let's say we take a look at sales by state. So we're going to group by state, and we're going to look at how much money we made in each of those states. There you go. Drag, drop. And we're actually going to sum. And I forget how many states we had. Is it just 5? Let's try 10. Because I didn't load too many states into the CSV file. All right, so now we can do the sales. We can see how much sales was made in each of these states. Let's press save and return. Oh, here it is. Oops, revenue by state. What am I doing? All right, so I think that's pretty much it. We're now able to enrich data when using Logstash and some bash scripts and the REST API. This concludes our tutorial series on data enrichment with Elasticsearch. If there's anything we missed, then just leave a question or comment, and we'll see if we can address that either through the comment section or in an upcoming video. If you found this video helpful, then give us a like, because then it'll tell us that we're doing a good job.